we're going to step away from tables for a bit, and we're going to look at some different types of graphs. The first graph we're going to look at is called a bar graph, also known as a bar chart or bar plot. It's a graph in which the frequency or relative frequency values of variables are represented by the lengths of rectangles. And the variables themselves are qualitative. Now that's going to be key because we're going to have graphs later where they're not qualitative, but they will look very similar. So bar graphs are the ones where the variables are qualitative. Now they can be vertical or they can be horizontal. The rectangles have to be the same width and they do not touch each other. That's another way you can spot the difference between a bar graph and one we're going to learn later called a histogram. Obviously, you should label your axes as always. It can be labeled with either the frequency or the relative frequency. And remember, we don't always use those terms. So we could say how many, or we could say percent, and that would mean the same thing. And they should be flat. They should be two-dimensional. You should not have three-dimensional graphs. How to graph them in StatCrunch, if you're interested, the instructions are right here. That's your path in StatCrunch. Would be graph and bar plot. You'll probably pick up on those when you do a project involving those for your instructor. Okay, so let's look at this example. We're going to use the bar graphs to answer the following questions. And these are real data, by the way. Whenever you see this in the notes, that means that those are real data sets that you could get. As a matter of fact, if you go to the electronic version of the course pack or ask your instructor, they can send you the links if you're interested. So graph A are video game movies. Right? And these are the different movie titles. Now you can see these are qualitative. This is a vertical bar graph, right? So this one's vertical. And over here it has the worldwide box office. Now it doesn't say frequency, but that's what it is, right? Because these are $100 million. So these are the frequencies. This is how many dollars were made, right? So if we're interested, this is frequency. This is a vertical bar graph, right? As opposed to graph B, which is actually horizontal. It's a horizontal bar graph. These are frequencies. And then let's look at some of the questions, right? How can you tell these graphs are bar graphs? Well, if I look at them, they have words on their axes, right? Their variables and categories are words. So the variables are qualitative, right? In this case, it's movie title. This one down here, it's actually the country, right? These are different countries. This is the market share of leading national pharmaceutical markets, right? So how much we spend on prescriptions, right, for different countries. There's the US right there, right? So this is worldwide market share. Okay, which graph is a relative frequency bar graph? Well, this one's frequency. This is worldwide box office. I know they're decimals, but they're not really because they're $100 million. You have to imagine multiplying these by 100 million. Whereas down here, these are percents. This is share right here. So these are all percents. And so therefore, this is relative frequency down here. So graph B is actually a relative frequency bar graph. So we're going to say graph B, right? And I'll make a little note. It's because they're percents, right? Percents are relative frequency. Actually, I thought I'd write it out because I didn't want you to get confused. Percent is relative frequency, right? Relative frequency is percent. How much money did all the Sonic movies make? Ooh, okay. So the Sonic movies, we would have to add up all the different Sonic movies. So there's Sonic the Hedgehog here. Oh, I think I'll use this one. Sonic the Hedgehog right there. And then Sonic the Hedgehog 2. And then Sonic the Hedgehog 3. So I would want to add up all three of those. So I'm going to go grab Desmos and add them. There's my Desmos. So 3.02 is the first one, 4.03 is the second one, and 4.89 was the third one. Together, all three of those make 11.94. All right, so we would say 11.94. So you might want to write it out. 3.02 plus 4.03 plus 4.89 makes 11. I already forgot what the number was. 94. 11.94 $100 million. That is a little awkward to write it that way. What you can do is multiply this by 100. So this would be the unit for this. So you could take 11.94, multiply it by 100. That would be 11940 because that would move the decimal 2 spots, right? Oops, it only moves it 2 spots. So 1194, that's what I meant to say. All right, 1194, right? Because this is 100, it moves it 2 spots over. And then you could say $1,000,000. So either one of these is perfectly fine. The $100 million is just a little awkward. We're not used to writing it like that. So, and I would want to separate it out so that it doesn't look like it's bleeding into this number. So that's why I put the parentheses there. So it might be cleaner just to multiply it by 100 and say that. Right? But either one of those is fine. All right, now how many countries have shown how many countries shown have at least 4% of the pharmaceutical market? Ooh, okay. At least 4%. That's a little bit of an interesting phrase. At least 4 means actually 4% or more, right? So least is kind of a strange word. It means you're at least that much or maybe more. So if I look at 4%, 4% would be here, here, and then anybody higher than 4%. This one, China. So China, Germany, Japan, oh, and of course the US. So there's 1, 2, 3, 4 countries. 4 countries have at least 4% of the pharmaceutical market. All right, now what does the US value of 44.4% mean in this context? Well, it means that we are way larger than the rest. These are the leading national pharmaceutical markets. And the US is more than 4 times as big as the nearest competitor, which is China. So the US spends a lot on prescription drugs, on pharmaceuticals, right? The US spends a lot on pharmaceuticals. I'm just going to abbreviate pharmaceuticals as RX, right? Prescription drugs. So spends a lot on prescription drugs, more than 4 times the nearest competitor. I'm just doing that 4 because 10 times 4 would be 40, and we're past that. I mean, actually, I think we're more than 5, right? Because 5 times 7 is 35, and we're past that. So more than 5 times as much as the nearest competitor. So the US is actually an outlier, which is a topic we'll get into more in the next chapter. But it means that we lie far out from the rest of the world in terms of pharmaceutical spending. We spend way more on prescription drugs as a country than any other country. China, with over 1 billion people, spends less than we do. So an outlier means no country is close to us. That's what you can take it to mean right now. We'll get a more formal definition later on in chapter 3. So, but for right now, we lie far out from the rest, hence outlier. We lie far out from the rest of the world.